In this video, we're given the percentage of carbon, hydrogen, and oxygen in a compound, and we're asked to determine the molecular formula given the molar mass. And first, we want to determine the empirical formula. And in another video on this playlist, I determined the empirical formula of a compound in a very similar manner. So in this video, I'm going to go through relatively quickly determining the empirical formula, and then do the new part where you have to determine the molecular formula. So the first thing we need to do is consider these percentages as grams. Said another way, we need to assume that we have 100 grams of compound. So if we have 100 grams of compound, that would be 40.92 grams of carbon. We want to convert grams of carbon to moles of carbon because the empirical formula is the simplest ratio of moles. So we put 1 mole of carbon over 12.01 grams of carbon, and to three significant figures, we get 3.41 moles of carbon. We want to do the same thing for hydrogen. 4.58 grams of hydrogen. Again, if we have 100 grams and it's 4.58%, we have 4.58 grams of hydrogen times 1 mole of hydrogen per 1.01 grams of hydrogen, which gives us 4.53 moles of hydrogen to 3 sig figs. Sig figs aren't super important here because we're trying to find the empirical formula, which is a whole number ratio of moles. Said another way, you just need the first digit. Finally, we have 54.50 grams of oxygen times 1 mole of oxygen per 16.00 grams of oxygen. Again, all these molar masses come from the periodic table, and you get 3.41 moles of oxygen. We now want to divide by the smaller number, and for both carbon and oxygen it's 3.41. So we want to divide everything by 3.41. In the case of carbon and oxygen, we get 1. But in the case of hydrogen, we have 4.53 divided by 3.41, which is 1.33. Since you can't have 0.33 of a hydrogen, and 0.33 is a third, what we want to do is multiply everything by 3. Now, as I mentioned in the previous video, in the lab, the instructor may tell you to roll it round to the nearest whole number because this could come from experimental error. But here, from a textbook example, it doesn't come from experimental error, so you need to multiply everything such that this gives you a whole number. So this means we're going to have C3H4O3. So the ratio is 3 to 4 to 3. Now we can do the empirical formula, which I just said is C3H4O3. Now we need to find the molecular formula given the molar mass. So the molar mass is equal to the empirical mass times some integer, which I'll label here as n. So we can basically now use this equation to find it. So first I need to find the empirical formula mass. So I want to do 3 times 12.01 plus 4 times 1.01. These are all from the periodic table, plus 3, the number of oxygens, times 16.00. And when I do all that, I find that the molar mass of this empirical formula, which I should have said is the empirical formula mass, is 88.07 grams per mole. And I'm just going to leave it as grams here. So the molar mass is 176.12. And since they use grams per mole, I will go ahead and use grams per mole here, equals 88.07 grams per mole, the empirical formula mass, the mass of the empirical formula that we just found, times n, some integer. So divide both sides by 88.07. And to the nearest whole number, n equals 2. which means that this formula must be doubled. So the molecular formula is double the empirical formula, so double everything. In this case, the C3 becomes C6, H4 becomes H8, and O3 becomes O6. So the molecular formula of this compound is C6H8O6.